Hello children, welcome to Math Park. We are going to solve question number 21 to 28, distance formula, exercise 28 from book Concise Selena class 9 ICSE. So this is the third part of this chapter. So if you like the video, please share with your friends, and if you are new to the channel, please subscribe. So we start with question number 21. The length of line PQ is 10 units and the coordinates of P are 2 minus 3. Calculate the coordinates of Q if its abscissa is 10. So let us take, this is the line PQ, okay, and the coordinates of P are 2 minus 3 and coordinates of Q, if abscissa is 10, so let us take the ordinate as y. So we have to find y now, where the length is given as 10 units. So because the length of this line is the 10 units, so we have PQ is equal to 10. So let us square both sides. So we get PQ square is equal to 10 square, which is 100. Using the distance formula, let us put the PQ square. So this is my, I'll take this as my x1, y1, and this is my x2, y2. So distance formula, you have x2 minus x1, that is 10 minus 2, the whole square, plus y2, that is y minus 3. So minus of minus 3 becomes y plus 3, the whole square, which is equal to 100. So 10 minus 2 is 8 square, which is 64. Let us use a plus b the whole square. So a square, that is y square, plus b square, that is 3 square is 9, plus 2ab. 2 times 3 is 6. 6y is equal to 100. And now we have here y square plus 6y. Now this is 64 plus 9 is 73. And 100, if this 100 comes here, it becomes 73 minus 100. So which we get as minus 27 is equal to 0. Got it? So what did we do? 64 plus 9, which was 73. And when this 100 moves here, we get 100 minus 73, which we get as 27. Now let us factorize this 27. We need to find the factors of 27 such that the difference is 6. So we have 9 times 3 is equal to 27. So here it is minus 27. The bigger one will have positive. So we get 9 times minus 3 is minus 27. We split the middle term, y square plus 6y, plus 9y minus 3y minus 27 is equal to 0. So we split this 6y as 9y minus 3y. Let us take common, y taken common from first two terms, we get y plus 9. And from here, minus 3 taken common, we get y plus 9, which is equal to 0. So we get either y plus 9 and y minus 3 is equal to 0. So these two are the factors. So if y plus 9 is equal to 0, we get, if y plus 9 is equal to 0, we get y is equal to minus 9. And if y minus 3 is equal to 0, we get y is equal to 3. So this is how we get the point. We get 2 points over here. We get the value of y as minus 9 or 3. So this is how the coordinates of Q can be either 10, because the abscissa was 10 here. Look at this point, 10 minus 9 or 10, 3. Question number 22, point 2 minus 7 is the center of the circle with radius 13 unit. PT is perpendicular to the chord AB and T is equal to minus, this coordinate of T are minus, the coordinates of T are minus 2 and minus 4. Coordinate of P here is 2 and minus 7. We are asked to find distance 80. The radius is given as 13 units and we are asked to find distance AB. So now, children, in the circles topic, we have learned that perpendicular from center bisects the chord. That means AT is equal to half of AB. It makes the perpendicular PT makes these two equal parts of AB. Using the Pythagoras theorem, before that we will be finding PT now. So according to Pythagoras theorem, we have AP square is equal to APT square plus AT square, right? So if I have to find AT square, it will be equal to AP square minus PT square. For that, let us find PT now. Directly, we are going to find PT square. So PT square, we will be using this point as, this is minus 2, minus 4. This will be my x1, y1. And 2 and minus 7 is going to be my x2, y2. So x2 minus x1, 2 minus of minus 2 becomes 2 plus 2 the whole square. plus y2 minus y1, that is minus 7 minus of minus 4 become plus 4. So minus 7 plus 4 the whole square. So 2 plus 2 is 4 square, which is 16, and minus 7 plus 4 is minus 3 square, which is 9, which we get as 25. Okay, and we already know that AP is equal to 13. So we have AP square is equal to 13 square, which is 169. Let us substitute over here. So we have AT square is equal to AP square minus PT square. That is 169 minus 25, which we get as 144. So if AT square is equal to 144, AT is equal to root 144, which is equal to 12 units. Now we got AT as 12 units. We know that perpendicular from center bisects the chord. Perpendicular from center bisects the chord. So therefore, you get AB is equal to twice AT, which is equal to 2 times 12, that is 24 units. Got it? So this is how we got AT as 12 units and we got AB as 24 units. Calculate the distance between the points P22 and Q54 correct to 3 significant figures. Okay, so this distance, so that means we will be getting the answer in decimals. So what are significant figures? I'm going to post the video of that in the description of this video. Do watch it if you have a doubt on significant figures. So let us find the distance. So we have, this is my x1, y1, and this is my x2, y2. So we use the formula PQ is equal to, if I use PQ, then it is going to be square root of x2 minus x1, that is 5 minus 2 the whole square, plus y2 minus y1, that is 4 minus 2 the whole square. So which we get as root of 5 minus 2 is 3 square, which is 9, and 4 minus 2, that is 2 square, which is 4. So 9 plus 4 is root 13. Now 13 is not a perfect square, right? So we will be finding the square root of 13. So find the square root of 13 by long division method. So finding the square root of 13. So we write 13 here. We put a bar on this. Take, long root we have already learned in 8th grade. So we look for the perfect square which is less than 13. It is 3 square, which is 9. So we start with 3. 3s are 9. So we subtract 13 minus 9, we get as 4. We add this 3 down. So 3 plus 3, you get 6. We bring these 2 zeros down. So now we have 400. So look for the number. What I will be putting against 6 here. The same number I have to put up there. So look for, you have 6. 6 are 36. So that means 60 times 6 is going to be 360. So let us check for 66 into 6. What do we get? 6 6 are 36. 3 here. 6 6 are 36 plus 3 is 39. 6 is a 36, 3 6 is a 39. So we get 6 are 396. Same number we put over here. Add the number which we have put in the quotient. We get here 6 plus 6, 12, 72. Now, if I put even 1 here, 721 into 1 is going to be more than this, the number what we are going to get after subtracting. So we subtract, we get 4 here. Bring this 2 down. So if I put 1 here, it is going to be more. So I put 720 multiplied by 0, which we get 0. So we get again add here plus 0. So we get 720 here. And 400 minus 0 is 400 again. Right, so I'll take again because they have asked to 3 significant figures. So let us find up to 3 decimal places and then round it up. So we put 2 more zeros over here. Bring those 2 zeros down. So we have now to put the number here again. So look for 7 3s are 21, 7 4s are 28, 7 5s are 35. So let us take 7205 times 5, what we get? 5 5s are 25, 2 here. 5 2s are 10, carry 1. 5 7s are 35 plus 1, 36. So we get 5s are 36025. We subtract this. We can stop here. No need. We have found it. Because if I go for a number more than this, this is going to go more. I can stop here. So square root up to 3 decimal places, I got 3.605. Now to find up to 3 significant figure, now all this number is up to 4 significant figures. So I go for the fourth figure, it is 5 or more, I should add 1 over here. So PQ distance up to 3 significant figures, I'll be adding 1 here. It is 3.61 up to 3 significant figures, 3s. Got it? Now let us move on to question number 23. So B is on x-axis and whose abscissa is 11. So the coordinates of B are going to be abscissa is 11. So if it is on x-axis, y coordinate is going to be 0. Okay, and we have to find the distance between these 2 points. So we get AB is equal to, let us take this as x1, y1. This is my x2, y2. So we find here a square root of x2 minus x1, that is 11 minus 7 the whole square plus 0 minus 3 the whole square. 11 minus 7 is 4 square, which is 16, and minus 3 square is 9. 16 plus 9 is 25, and root 25 we get it as 5 units is the distance AB. Got it? Question number 25. Calculate the distance between A, 5, 3 and B on y-axis. So ordinate is 5. So the coordinates of B, the coordinate of B, the ordinate is called as y coordinate. And since the point is lying on y-axis, the x coordinate is going to be 0. So we have A 5 minus 3 and B 0, 9. So let us take, this is my x1, y1 and this is my x2, y2. Let us find the distance between AB. So AB is equal to square root of x2 minus x1, that is 0 minus 5 the whole square, plus y2 minus y1, that is 9, minus of minus 3 is going to be plus 3. So we get this as minus 5 square is 25, and 9 plus 3, 9, this is going to be plus 3, 9 plus 3, that is 12 square, which is going to be 144. So 25 plus 144, we get 169, and square root of 169, it is 13 units. Got it? Find the point on y-axis whose distance from the points A 6, 7 and B 4 minus 3 are in the ratio 1:2. Now the point is on y-axis. So let the coordinates of that point be, since it is on y-axis, x coordinate be 0. So it will be 0 and y. Okay. Now it says that the find point on y-axis whose distance from the point A, and this is in the ratio this. So suppose A is this 0.67 and B is another 0.4 minus 3. So there is one point which is P over here, and the distance between AP and BP, the distances are in the ratio 1:2. So if I have a point P over here, the coordinates of P are 0, y, which is on y-axis, and then the distance between these 2 points is 1:2. That is, you have AP upon BP is equal to 1/2. So that means you have twice AP is equal to BP. Getting it? The ratio 1:2. So then, since the distance is to be calculated, let us square both sides. So if I square both sides, I get 4AP square is equal to BP square. Now I'm going to use the distance formula for AP and BP. So when I'm using AP, this is, I'm going to use this as x1, y1 now, and then this as x2, y2. So AP square, so 4 AP square, if I am taking, it is 6 minus 0, x1 minus x2 minus x1 the whole square is going to be 0 minus 6 the whole square. I'll put this in the bracket because 4 multiplied by AP square plus y minus 7 the whole square. Okay, this is my AP square is equal to BP. Now, when I'm using BP, I'll be using this as x1, y1. So 0, this is 0 minus 4 the whole square plus y minus of minus 3 becomes y plus 3 the whole square. Got it? So let us simplify 4, 6 square minus 6 square is 36. Y minus 7 the whole square is y square plus 49 minus 14y 2ab, okay, is equal to, again 4 square is 16 plus y square, this is plus 9 a plus b the whole square plus 2ab, that is we get 6y. Okay, let us multiply by 4 here. So 36 into 4, we get it as at 144. plus 4 into y square is 4y square. Again, we have 49 into 4, multiply 49 into 4, you get it as 196. So plus 196 minus 4 into minus 14y. So 14 times 4, we get it as minus 56y. So we multiplied by 4 over here. So this is 16 plus y square plus 9 plus 6y. Okay. Now let us simplify this further. So we have, we'll bring this y square over here. So 4y square minus y square, we get this as 3y square. Okay. Now this is 44 plus 96. Let us add this 144 plus 196. We get 6 plus 4, 10, carry 1. 9 plus 1, 10 plus 1, 14, carry 1, 340. Okay. Now this is 340. If I bring this 16 plus 9, 25 here, you'll have to subtract. So minus 25, which we get as 315. So this is going to be 315 when this comes over here. Now we have middle term, that is minus 56 plus 6y comes here, becomes minus 6y. So 56 plus 6 becomes, we have 56 plus 6, we get 62. So we get here minus 62y, and this becomes plus 315 is equal to 0. So we got this equation. Now this is an equation which cannot be uh, factorized by using splitting the middle term. We know that if b square minus 4ac is not a perfect square, we cannot factorize by splitting the middle term. So we will be now using the quadratic formula the way we have done in exercise, same exercise question number 20. So the quadratic formula, we have minus b plus or minus root b square minus 4ac upon 2a. So you have a is equal to 3, b is equal to minus 62, and you have c is equal to 315. So let us put in the formula x is equal to minus b. So minus of minus 62 is going to be 62 plus or minus square root of b square, that is 62 square minus 4ac, 4 into 3 into 315. Let us simplify this further. So we have 62 plus or minus 62 square. When we do 62 square, we get it as 3844. 3844. Then multiply this 4 into 3, 12. 12 into 315. 12 into 315, you get 3780. Subtract this, you get 3844 minus 3780. 3844 minus 3870. We get 64. So we get 62 plus or minus root 64. Oh, sorry, upon 2a, I forgot to write. This whole upon 2a, that is 2 times a is 6. 2a is 6. 2 into 6. So this whole upon 6 and this whole upon 6. So we get this as 62 plus or minus root 64 is 8 upon 6. So x is equal to this. So we get x is equal to 62 plus 8 upon 6, or x is equal to 62 minus 8 upon 6. So we get the value of x as 62 plus a, which is 70 by 6. This can be 35 by 3. Or x is equal to 62 minus 8. If I do, I'm getting 54 by 6, which is equal to 9. So this is how the coordinates, find the point on y-axis, the coordinate of y, the point P, we get it as, so the coordinates of point P are either, P is either 0, 35 by 3, or it is, P is 0, 9. Understood? Okay, so this is our final answer. The distances of point P, x, y from the points A, 1 minus 3 and b minus 2, 2 are in the ratio 2:3. Show that. Okay, this is again easy. Just solve with the steps p, x, y and this. So we have distances are in the ratio 2:3. So that means you have AP upon BP is equal to 2 upon 3. So you have 3 AP is equal to 2 BP. Or you can say that squaring both sides, you get 9 AP square is equal to 4 BP square when we square both sides. So let us use the distance formula. This is my, if I take this as x1, y1 for AP, so I get 9 in bracket AP square. So x This is my x2, y2. So if I take this is x minus 1 the whole square plus y minus of minus 3 is y plus 3 the whole square. So done with AP square is equal to 4 BP square. Now for BP square, now this will be my x1, y1. So I have x minus of minus 2 becomes x plus 2 the whole square plus y minus 2 the whole square. Let us expand this carefully. So we have 9, let it be in the outside the bracket. X minus 1 the whole square is x square plus 1 minus 2x. Y plus 3 the whole square is y square plus 9 plus 6y is equal to 4 in bracket. X plus 2 the whole square is x square plus 4 plus 2 2s are 4x. Y minus 2 the whole square is plus y square plus 4 minus 2 2s are minus 4y. Okay. So now again, we need to multiply each term inside. So let us simplify inside first. 9, you have here x square plus y square minus 2x plus 6y and 9 plus 1, this is 10. Here we have 4 x square plus y square plus 4x minus 4y. 4 plus 4, it is plus 8. Okay, we will be now expanding this bracket. So we'll be multiplying by 9. 9x square plus 9y square minus 9 2s are 18x. 9 6 are 54y. 9 times 10 is 90 is equal to 4 into x is 4x square. 4 into y square is 4y square. 4 4s are 16x. 4 into minus 4y is minus 16y. 4 8s are 32. Okay, let us start here now. The place is less. So we'll bring everything on the left hand side. So we have 9x square, we'll bring 4x square here, minus 4x square, plus 9y square, take this 4x square, that's, sorry, 4y square, there it becomes minus 4y square. Then we have minus 18x, and then this 16x goes here, it becomes minus 16x. We have plus 54y. So this minus 16y goes here, becomes plus 16y. Then we have plus 90 here. This 32 goes here, becomes minus 32, which is equal to 0. We shifted all the terms on right hand side to the left hand side. Now 9x square minus 4x square is 5x square. 9y square minus 4y square is 5y square. Minus 18x minus 16x is minus 34x. 54y plus 16y is 70y. 90 minus 32 is plus 58, and this is equal to 0. Hence, we proved it. Got it? We did with question 27. The last question of this exercise, the point A30, B A minus 2, C4 minus 1 are the vertices of a triangle ABC right angled at vertex A. Find the value of A. So here what we'll do is, let us take this as a right triangle. It is right angled at A. So let us write this right angled at A. A ka vertices are 3, 0. And let us take this point B. The vertices of B are A and minus 2. Vertices of C are 4 and minus 1. And it is right angled at A. You have to find the value of A. Now here we will be using the Pythagoras theorem. We know that this is BC is my hypotenuse. So we have AB square plus AC square is equal to BC square. Okay. So let us use the distance formula. Substitute the values. For finding AB square, let us use this. This is A minus 3. So AB, I have A minus 3 the whole square. That is x2 minus. Then I started from here. So minus 2 minus 0 the whole square plus minus 2 minus 0 the whole square plus CA. So when I am finding CA, I can take this 4 minus 3 the whole square plus minus 1 minus 0 minus 1, sorry, minus 1 minus 0 the whole square. We did with this part, which is equal to BC square. Now BC square is A minus 4 the whole square. This is A plus minus 2 minus of minus 1 becomes plus 1 the whole square. Let us simplify. A minus 3 the whole square is a square plus 9 minus 2ab becomes minus 6a. Okay. Minus 2 square is plus 4. 4 minus 3, 1 square is plus 1. Minus 1 square is again 1, which is equal to a minus 4 the whole square is a square plus 4 square, which is 16. And minus 2ab, so it becomes minus 8a. And minus 2 plus 1 is minus 1 square is 1 again. So this 1 and 1, let me cancel. It is going to be 1 minus 1. A square and a square will get cancelled. Let us bring all the terms with a on one side. So minus 6a is here. I'll bring this minus 8a. It becomes plus 8a. And this is 9 plus 4, 13 plus 1, 14. So which goes here, 16 minus 14 it becomes. So minus 6a plus 8 is 2a is equal to 16 minus 14 is 2. So a is equal to 2 upon 2, which is equal to 1. So we are done with this exercise, children. So if you like it and if this has helped you, please help others by sharing it. Thank you for watching. Have a good day.